So for this program, we use different commands. We use the move L command, the move J command, and then over here the move C command. These three types of commands takes an input, a point that has been predefined or that has been learned previously by the robot. In this case, this move L command, that it stands for a linear movement, it uses as an input the P corner 1 point. Move J command, that is a joint movement, uses here the point AB corner 1, and circular movements that they differ from linear and joint movements. They take as an input 2 points, a midpoint and the end point. So from whatever position the robot stands, it's going to reach P point 3, passing through P point 2. Okay, so we can also see here that these are the declarations of each point. They are managed as a constant at the beginning of the code, and it's the position of each point with reference to the world. It also includes its orientation. What else? Here, these variables v and z. V is the velocity at which the movement will occur, and it's the velocity at which the robot is going to move. Z, it's the approach parameter. When going from one type of movement to another, the simulation creates like a small sphere of size, in this case 100, and if the tool point of the robot passes through that zone, it's going to start to deflect to the next movement, making the transitions between movements more natural or softer. Here in this case, this is like saying that z is equal to 0, so it's there are linear and cold movements. So for example, this type of movement is a 90-degree movement. It goes in one line and then to another direction. And because it's fine, the transition between 1 and 2 is cold. So it's going one way and then it goes straight in a 90-degree angle. If we have this C value, the transitions between one another would be curved. So it's going this way and then this way, but passing through a little curve here. Okay. Another thing that we need to learn here, well, let me explain the code a little bit. This is just going from it's whatever the position it is, it goes to the home point, then it goes to a point above one of the corners, then it goes to that corner, and this part it goes around the four corners of a box, then it goes to the point above the corner, and then all again to home. So the cycle repeats here, but we added this little path that travels in the edge of a circle, of a cylinder. So from whatever it is, it goes to a point above the cylinder, and then here is the tour in the perimeter of the cylinder, in the face. It touches the cylinder here, and it makes a circular movement to point 3, passing through point 2, and then it goes to point 1, passing through point 4, and then it retreats from the cylinder, and it just goes to home again. What I wanted to show you is what to do or when we make changes in the code. For example, if I say here is some change, we see in the left that the status bar goes yellow, meaning that there's change that hasn't been applied. So we use the button here up there to apply the changes, and now our code is up to date, but our simulation is not. So we just go to here, synchronize, and we synchronize our code to the station simulation here. So we just click that and we select everything to be synchronized. We click OK. It gives us a ready go, and then we can just go to the simulation. Here we can see the simulation and the path that has been marked. The place where it is right now is the P home, or the home point, and it goes to the above point, goes around the perimeter of the box, it retreats back to the point home, and then it goes to the cycle of the cylinder. So we're just gonna see that the changes have been applied correctly. We can use play to see how the simulation works. It goes around the perimeter here, and you can see the turns are sharp between movement and movement. Here is the circular movements.